This is a quick video over absorption. Adsorption. And what it is you have a surface. And let's say that surface is negatively charged. And then you have particles that are positively charged. What absorption is when the particles hit the surface and stick to it. So this is only for, by our definitions of at least the equations I'll be providing, they only stick to the surface and they do not stick to each other. So there's not one that's sticking right on top of all these that just make piles. It's just flat and straightforward of just non-sticking. So first we need to, before we can put into the equations, we need to define some variables. And we're going to say Cb is equal to the concentration of solute in solution. So Cb is these atoms. That's all it is. Cb is just those atoms that are still floating around and that are not on the surface. Next is Qb, little qb, and it is equal to the concentration of solute on surface. Surface. So it's the number of these on the surface. That is QB. Next is Q, capital Q, and it is the volume of liquid. And next is S, and it's the mass of absorbent. So that's the mass of this maybe block or something. And the reason that you use mass is you can use the mass and replace for the surface. So really you can think of S as the surface area, but not completely. It's just a number, because you can't really measure the area very easily. So instead of being able to try to find that, we just go ahead and just use the mass of the adsorbent. And QB and S must, you can have QB, I won't even mess with that, never mind. So if we just do Q, which is the volume times the concentration of the solute in the fluid, it is equal to, oh sorry, that's QB naught. QB naught is equal to QCB, oops, sorry, might as well, times CB, what's actually in the solution at the moment, plus S times little qb. So, and we get that, we have a concentration, and a concentration. This is a volume, so it becomes a mass, and it equals out. So if we do a little bit of rearranging and try to solve for QB, and we'll just have Q I guess I'll just do it. Q times CB naught, oops, CB naught minus Q times CB is equal to QB, and we're just going to divide by S. So yeah, So, I mean, I guess we could have just divided by S up here first and just. And this was the mass balance information. So that gives us the mass balance information, where we have CB on the bottom and QB on the right. So next, we're going to do the equilibrium information. And so equilibrium information is we have sites open and we have things falling down. So this is coming down, this might be popping up, this might be coming down, this is popping up, or it's just staying there. And with that, we can find that we'll have K EQ. We'll say it is equal to the bound sites, or bound solute, over unbound solute, bound solute, not doing that perfect, times the open sites. And we actually know what these are. We know that it's actually GB, or sorry, QB over CB with the open sites. And we're going to assume that the open sites are always open. There's just a ton of them. So we're actually just going to move that over here and then call QB over CB equal to K, and then we get an equation where QB is equal to K CB. And this is only for when you have very little solutes and a ton, or just a lot of the adsorbent. So, and this is linear, so it goes something like that, and then where they combine is where your system's at. So you have your mass and you have your equilibrium information. And again, you have this K EQ, and you're just gonna move that open site over there because you're gonna assume that it's always open. The next video, I'll go over what happens when it is no longer open.